Moving on to the first question. State which of the pair of triangles in figure 6.34 are similar. Write the similarity criterion used by you for answering the question, and also write the pair of similar triangles in the symbolic form. Now moving on to the solution. Let us consider the two triangles in the first bit. Here, angle A in the first triangle is equal to angle P in the second triangle PQR, and also angle B is equal to angle Q, and angle C is equal to angle R. Now in these two triangles, according to A similarity, as all three angles are equal, we can say triangle ABC is similar to triangle PQR. Now moving on to the solution for second bit of first problem. Here let us take the ratio of sides, that is consider AB by QR, that will be equal to 2 by 4, which is nothing but 1 by 2. And in the second case, let us consider BC by PR, which will be equal to 2.5 by 5, that is nothing but 1 by 2 again. And finally, let us consider the ratio of AC by PQ, which is nothing but 3 by 6, that is equal to half. So as all the ratio of sides, that is the ratio of corresponding sides, that is AB by QR is equal to BC by PR is equal to AC by PQ. So finally we can say that triangle ABC is similar to triangle A corresponds to Q, and B corresponds to R, and C corresponds to P. Finally, we can say that triangle ABC is similar to triangle QRP according to triple similarity, as all sides correspondingly are in proportion. Now moving on to the solution for third bit. Let us consider the ratio of sides, that is MP by DE, which is equal to 2 by 4, that is 1 by 2. And also if we consider the ratio of sides, that is LP by DF, which is equal to 3 by 6, nothing but half. And here LM by EF is equal to 2.7 by 5. Here only two corresponding sides ratio is in proportion. So we can say that the given triangles are not similar. Now moving on to the solution for fourth bit. In triangle LMN and PQR, angle M is equal to angle Q is equal to 70 degrees, and MN by QR is equal to 2.5 by 10, which is nothing but 1 by 4. And here ML by PQ is equal to 5 by 6. Here angle is equal, but corresponding sides, none of them are in proportion. So we can say that the given triangles are not similar. Now moving on to the solution for fifth bit of first problem. Here angle A is equal to angle F is equal to 80 degrees and AB by DF is equal to 2.5 by 5, which is nothing but 1 by 2, and also BC by EF is equal to 3 by 6, which is 1 by 2. Therefore AB by DF is equal to BC by EF. Here the corresponding angles is equal and the two of the corresponding sides are in proportion. So by SAS similarity we can say that triangle ABC is similar to triangle FED. Now moving on to a solution for 6th bit. Here two angles of a triangle are given, that is angle D is equal to 70 degrees and angle E is equal to 80 degrees. Let us find angle F. We know that sum of angles in a triangle is 180 degrees. Here F will be equal to 180 minus 70 degrees plus 80 degrees, which is nothing but 30 degrees. So here we got F as 30 degrees. And in triangle PQR, we know that sum of angles is equal to 180 degrees. He has given the angles Q and R. So let us find angle P is equal to 180 degrees minus sum of two angles, that is 80 degrees plus 30 degrees, which is nothing but 70 degrees. So here we got angle P as 70 degrees. In these two triangles, angle D is equal to angle P and angle E is equal to angle Q and angle F is equal to angle R. Therefore, by AAA similarity, we can say that triangle DEF is similar to triangle PQR. Moving on to a third question. Diagonals AC and BD of trapezium ABCD with AB parallel to DC intersect each other at the point O. Using the similarity criterion for two triangles, show that OA by OC is equal to OB by OD. Now moving on to solution. Let us consider a trapezium ABCD with AB is perpendicular to DC and BD and AC be the diagonals intersecting at O. Then we are required to prove that OA by OC is equal to OB by OD. Now in order to prove that, let us consider the two triangles OAB and OCD. In these two triangles, angle AOB will be equal to angle DOC since they are vertically opposite angles. Those will be equal about the common intersection point. And also, as AB is parallel to DC, angle C will be equal to angle A. As they are alternate interior angles with AB parallel to DC and CA as transversal. Now again, angle D will be equal to angle B since they are also alternate interior angles when AB is parallel to DC and DB as transversal. Here, according to AAA property, triangle AOB is similar to triangle COD. We know that when two triangles are similar, then their corresponding sides will be in proportion. So here we can say the corresponding sides, that is OA by OC, will be equal to OB by OD is equal to AB by CD. Here we need only the first two terms of proportionality, that is OA by OC is equal to OB by OD, which is the proof required for us. In figure 6.36, QR by QS is equal to QT by PR and angle 1 is equal to angle 2 show that triangle PQS is similar to triangle QTR. Now moving on to the solution. Let us note down the given information, that is QR by QS is equal to QT by PR and angle 1 is equal to angle 2. We are required to prove that triangle PQS is similar to triangle TQR. Now moving on to the procedure. If we consider in triangle PQR, angle 1 is equal to angle 2. We know that in triangle the sides opposite to equal angles will be equal. We can say PQ is equal to PR here. So let us replace the proportionality PR by PQ. Then we get QR by QS is equal to QT by PR. Replace it by PQ. Now if we consider this proportionality and compare it in triangle PQS and triangle TQR, now this can be written as, by cross multiplication, PQ by QS is equal to QT by QR. Now if we consider in triangle PQS and triangle QTR, PQ by QS is equal to QT by QR. So here two of the corresponding sides are in proportion and also angle SQP is equal to angle RQT, which is a common angle in both the triangles. Angle SQP is equal to angle TQR, which is common angle in both the triangles. So finally, therefore, by SAS similarity, we can say that triangle PQS is similar to triangle TQR. Moving on to fifth question. S and T are points on sides PR and QR of triangle PQR such that angle P is equal to angle RTS. Show that triangle RPQ is similar to triangle RTS. Now moving on to solution. He says that there is a triangle PQR in which S is a point on PR, let it be here somewhere, and T is a point on QR. Now he says that angle P, which is nothing but angle QPR, is equal to angle RTS. So he has given that angle P is equal to angle RTS. Here angle P is nothing but angle QPR is equal to angle RTS. Now he asked us to prove the similarity between triangle RPQ and triangle RTS. So let us consider them. In these both triangles, angle QPR is equal to angle RTS, it is given. And in these both the triangles, angle PRQ is equal to angle TRS, since it is a common angle for both the triangles. Angle QRP is equal to angle SRT, since it is a common angle. So now by angle similarity, we can say triangle RPQ is similar to triangle RTS. This is what the required proof for us. Moving on to the sixth question. In figure 6.37, if triangle ABE is congruent to triangle ACD, show that triangle ADE is similar to triangle ABC. Now moving on to solution. He has given that triangle ABE is congruent to triangle ACD. We know that when two triangles are congruent, then their corresponding sides will be equal. So here AB is equal to AC and the corresponding sides, that is BE, is also equal to CD, and AE will be equal to AD. Now we are required to prove that triangle ADE is similar to triangle ABC. So let us consider in triangle ADE and triangle ABC, that is ADE is over here and ABC is a larger triangle. In this angle DAE will be equal to angle BAC, that is this angle, which is a common angle for both the triangles. Now here let us consider the two equations, that is AB is equal to AC and AE is equal to AD. Now AE is equal to AD can be also written as AD is equal to AE, which implies, let us divide both the equations, then we get AB by AD is equal to AC by AE. So here if we observe clearly, the corresponding sides, that is AB in triangle ABC by AD in triangle ADE is equal to AC in triangle ABC by AE in triangle ADE. Therefore here two corresponding sides in proportion and one of the angle is equal. So therefore by SAS similarity, we can say that triangle ADE is similar to triangle ABC. Moving on to the seventh question. In figure 6.38, altitudes AD and CE of triangle ABC intersect each other at point P. Show that in the first case, triangle AEP is similar to triangle CDP, and in the second case, triangle ABD is similar to triangle CBE. In the third case, triangle AEP is similar to triangle ADB, And in the fourth case, triangle PDC is similar to triangle BEC. Now moving on to solution. Let us first prove for the first case, that is triangle AEP is similar to triangle CDP. So in order to prove this, let us consider the both triangles, triangle AEP and triangle CDP. In the figure, triangle AEP is this and triangle CDP is this. In this, angle CDP is equal to angle AEP is equal to 90 degrees. As we know that CE is perpendicular to AB and AD is perpendicular to BC. And also angle CPD is equal to angle APE because they are vertically opposite angles about the common point P. So vertically opposite angles about the common point will be equal. So here we can equate angle CPD is equal to angle APE since they are vertically opposite angles. Now by AA similarity, as two corresponding angles in two triangles are equal, we can say triangle AEP is similar to triangle CDP. This is what our first proof we required. Now let us move on to the second bit. Here we need to prove that triangle ABD is similar to triangle CBE. So in order to prove this, let us consider both the triangles, that is triangle ABD and triangle CBE. Here if we observe the figure, the two triangles are triangle ABD and triangle CBE. So in this, if we consider angle ADB is equal to angle CEB is equal to 90 degrees, as CE is perpendicular to AB and AD is perpendicular to BC. And in this both the triangles, angle B is common, that is angle EBC is equal to angle ABD, since it is a common angle for both the triangles. Therefore, by AA similarity, as two corresponding angles in both the triangles are equal, we can say triangle ABD is similar to triangle CBE. Here in the third bit, we need to prove that triangle AEP is similar to triangle ADB. Now in order to prove this, let us consider both the triangles, that is triangle AEP in the figure and triangle ADB. In this, angle AEP is equal to angle ADB is equal to 90 degrees, as CE is perpendicular to AD and AD is perpendicular to BC. And also in both the triangles, angle A is common, that is angle PAE is equal to angle DAB, as it is a common angle in both the triangles. Therefore, by AA similarity, as two corresponding angles in both the triangles are equal, we can say triangle AEP is similar to triangle ADB. Now moving on to the fourth bit, we need to prove that triangle PDC is similar to triangle BEC. That is, triangle PDC is over here and triangle BEC which is over here. So in this, angle PDC is equal to angle BEC is equal to 90 degrees, as CE is perpendicular to AB and PD is perpendicular to CB. And also here in both the triangles, C will be the common angle. So here angle PCD is equal to angle ECB, since it is a common angle for both the triangles. Therefore, in both the triangles, two angles are equal. By AA similarity, we can say that both the triangles are similar. So triangle PDC is similar to triangle BEC. Moving on to the 8th question. E is a point on side AD, producer of a parallelogram ABCD, and BE intersects CD at F. Show that triangle ABE is similar to triangle CFB. Now moving on to solution. Let us consider a parallelogram ABCD in which BE is producer, AD is producer to somewhere, and from B line is drawn which intersects DC at F and intersects the extension of AD at E. So here E asked us to prove the similarity of ABE triangle, that is ABE, and CFB triangle. Here now, as he asked us to prove the similarity between triangle ABE and triangle CFB, let us consider both the triangles. That is, in triangle ABE and triangle CFB, that is, ABE is over here and CFB is over here. In this, angle A will be equal to angle C, as opposite angles in a parallelogram are equal. And if we consider that BC is parallel to AE and BE as transversal, then angle AEF will be equal to angle CBF, because they are alternate interior angles. That is, angle AEB is equal to angle CBF. So from 1 and 2, in both triangles ABE and CFB, the corresponding angles are equal. Therefore, by AA similarity, as two angles of two triangles are same, we can say triangle ABE is similar to triangle CFB. This is what the required proof for us. Moving on to the 9th question. In figure 6.39, ABC and AMP are two right angle triangles, right angle at B and M respectively. Prove that triangle ABC is similar to triangle AMP And second thing, CA by PA is equal to BC by MP. Now moving on to solution. Here in the first case, he asked us to prove that triangle ABC is similar to triangle AMP. So let us consider both the triangles. So in triangle ABC and triangle AMP, angle ABC is equal to angle AMP is equal to 90 degrees, as he has given that ABC and AMP are right angle triangles, right angle at B and M respectively. And second thing, angle CAB is equal to angle MAP, as it is common angle in both the triangles. Therefore, here as in both the triangles, two corresponding angles are equal, we can say by angle-angle similarity, triangle ABC is similar to triangle AMP. We know that, this is our first proof, we know that when two triangles are similar, then corresponding sides will be in proportion. So here AB by AM is equal to BC by MP is equal to CA by PA. If we consider the last two terms of proportion, then we get CA by PA is equal to BC by MP. This is what our second proof required. Moving on to 10th question. CD and GH are respectively the bisectors of angle ACB and angle EGF such that D and H lie on sides AB and FE of triangle ABC and triangle EFG respectively. If triangle ABC is similar to triangle FEG, show that CD by GH is equal to AC by FG, triangle DCB is similar to triangle HGE, and triangle DCA is similar to triangle HGF. Now moving on to solution. Let us consider two triangles, that is triangle ABC and triangle EFG. He says that CD is bisector of angle ACB, that is, let us name the D point here such that CD bisects angle C here, and GH is bisector of angle G. So this will be the condition. Now here he has given that triangle ABC is similar to triangle FEG. Here we can equate the corresponding angles, that is angle ACB is equal to angle FGE. Now in the first case, he asked us to prove that CD by GH is equal to AC by FG. So CD by GH is equal to AC by FG. Now in order to prove this, let us consider two triangles, that is triangle ACD and triangle FGH. If we are able to prove that similarity between these two triangles and thereby applying the concept that corresponding sides of two similar triangles will be in proportion, we can get the relation. So in triangle ACD and triangle FGH, angle A will be equal to angle F, as triangle ABC is similar to triangle FEG. As we know that angle ACB is equal to angle FGE, here angle ACD will be equal to angle FGH. Here FGH is of angle FGE. So now we can write angle ACD is equal to angle FGH. Now in both the triangles, according to angle property, triangle ACD is similar to triangle FGH. When two triangles are similar, then their corresponding sides will be in same proportion. So here let us note down the corresponding sides, that is AC by FG is equal to CD by GH is equal to AD by FH. Now let us consider only the first two terms of the similarity. Then we get CD by GH is equal to AC by FG. This is what our first proof required. In the second problem, he asked us to prove that triangle DCB is similar to triangle HGE. So in order to prove this, let us consider both the triangles, that is triangle DCB and triangle HGE. Here in triangle DCB and triangle HGE, angle B will be equal to angle E, as triangle ABC is similar to triangle FEG, and we have that angle ACD is equal to angle FGE, which implies here, as CD is bisector of angle ACB, we can write ACB as 2 times angle DCB is equal to, here similarly in this also, 2 times angle HGE, which implies angle DCB is equal to angle HGE. Now in both the triangles DCB and HGE, two angles that are correspondingly equal. So by angle similarity, we can say that triangle DCB is similar to triangle HGE. In the third bit, he asked us to prove the similarity between triangle DCA and triangle HGF. While proving the first proof itself, we proved that, first bit solving, we proved that triangle ACD is similar to triangle FGH. We can say that by interchanging the parts correspondingly, we get the similarity of same triangles. So we can write triangle ACD similar to triangle FGH as triangle DCA similar to triangle HGF. We just interchanged the Moving on to 11th question. In figure 6.40, E is a point on side CB produced of an isosceles triangle ABC with AB is equal to AC if AD is perpendicular to BC and EF is perpendicular to AC. Prove that triangle ABD is similar to triangle ECF. Now moving on to solution. As he asked us to prove the similarity between two triangles, that is triangle ABD and triangle ECF, let us consider both the triangles. In triangle ABD, and triangle ECF. Let us note down the similarities, that is angle ADB is equal to angle EFC, since those are equal to 90 degrees, as EF is perpendicular to AC and AD is perpendicular to BC. And next, let us equate angle C in triangle EFC equal to angle ACB, as it is a common angle for the triangle EFC and ABC. So now angle ECF is equal to angle ACB. Now, as ABC is isosceles triangle with AB is equal to AC, we know that angles opposite to equal sides in a isosceles triangle is equal. Here angle ABC will be equal to angle ACB, which implies angle ACB is equal to angle ABC. Angle ABC here is nothing but angle ABD. So now by equating angle ACB is equal to ABD, we get angle ECF is equal to angle ABD. Now if we consider this as first equation and this as second equation, these are two corresponding angles in triangles ABD. Now if we consider equations 1 and 2, these are corresponding angles in triangles ABD and ECF. So as two corresponding angles of triangle are equal, by AA similarity we can say triangle ABD is similar to triangle ECF. Moving on to the 12th question. Sides AB and BC and median AD of triangle ABC are respectively proportional to sides PQ and QR and median PM of triangle PQR. Show that triangle ABC is similar to triangle PQR. Now moving on to solution. Let us note down the given information, that is sides and median of triangle ABC and PQR are in proportion. So we can say AB by PQ is equal to BC by QR. It is equal to medians, that is AD by PM. Now that implies AB by PQ is equal to BC can be written as 2 times BD, as AD is a median for BC, by QR can be written as 2 times QM, that is equal to AD by PM, which implies AB by PQ is equal to, here 2 and 2 will be cancelled, BD by QM is left, which is equal to AD by AM. Now here if we observe, AB by PQ is equal to BD by QM is equal to AD by PM. So here in two triangles, that is in triangle ABD and triangle PQM, the corresponding sides are in proportion. So by triple similarity we can say triangle ABD is similar to triangle PQM. Now as two triangles are similar, we can say the corresponding angles will be equal. So here I am equating angle ABD is equal to angle PQM, which is nothing but angle ABC is equal to angle PQR. And also in triangle ABC and PQR we have AB by PQ is equal to BC by QR. By using this, that two corresponding sides of two triangles, that is PQR and ABC, are in same proportion and one of the angle is equal. So therefore by SAS similarity we can say triangle ABC is similar to triangle PQR, which is the required proof for us. Moving on to the 13th question. D is a point on side BC of triangle ABC such that angle ADC is equal to angle BAC. Show that CA square is equal to CB into CD. Now moving on to solution. Let us consider triangle ABC in which D is a point on BC such that angle ADC is equal to angle BAC. Now he asked us to prove that CA square is equal to CB into CD. In order to prove this, let us consider triangle ADC and triangle BAC. In this, angle ADC is equal to angle BAC since he has given, and here angle ACD is equal to angle ACB since it is a common angle for both the triangles. Therefore, as two angles that are correspondingly equal, we can say by AA similarity triangle ADC is similar to triangle BAC. Therefore, we know that when two triangles are similar, then corresponding sides will be in proportion. So here we can write AD by AB or BA is equal to DC or CD by AC can also be written as CA, which is equal to AC, that can be written as CA by CB. Now in this equality, let us consider the last two terms, that is CD by CA is equal to CA by CB. Now by cross multiplication we get CD into CB is equal to CA into CA on right hand side, then it is nothing but CA square, which implies finally we can write CA square is equal to CD into CD. This is a required proof for us. Moving on to 15th question. A vertical pole of length 6 meters casts a shadow 4 meters long on the ground, and at the same time a tower casts a shadow 28 meters along. Find the height of the tower. Now moving on to solution. There is a vertical pole of 6 meters which casts a shadow of 4 meters, and there is another tower which casts a shadow of 28 meters, but its height is not given. He has asked us to find. Let it be as h meters. So let us assume that AB be the vertical pole and BC be the shadow casted by it. Then ABC forms a right angle triangle, and similarly let us assume that PQ be the tower and it casts a shadow QR. Now this also forms a right angle triangle PQR, with Q is equal to 90 degrees. Now, if we consider in triangle ABC and triangle PQR, angle B is equal to angle Q is equal to 90 degrees and angle A is equal to angle P as shadow is cast at same time. So, in triangle ABC and triangle PQR, two corresponding angles are equal. So, by angle-angle similarity, we can say that triangle ABC is similar to triangle PQR, and we know that when two triangles are similar, then corresponding sides will be in proportion. So here corresponding sides, that is AB by PQ is equal to BC by QR, which implies AB here is 6 by PQ is H, which we need to find, is equal to BC is 4 meters and QR here is 28. That implies on cross multiplication we get H is equal to 6 into 28 by 4, and here 4 goes in 28 7 times, and finally we get 6 into 7 is 44. Therefore, height of tower is equal to 42 meters. Moving on to 16th question. If AD and PM are medians of triangles ABC and PQR respectively, where triangle ABC is similar to triangle PQR, prove that AB by PQ is equal to AD by PM. Now moving on to solution. He has given two triangles, that is triangle ABC, in which AD is a median to BC, and he has given a similar triangle to ABC, that is triangle PQR, in which PM is median. So he has given that triangle ABC is similar to triangle PQR. He asked us to prove that AB by PQ is equal to AD by PM. In order to prove that, let us consider triangle ABD and triangle PQM. In these two triangles, angle ABD will be equal to angle PQM, as ABC is similar to PQR. The corresponding angles in these both triangles will be equal. So angle B is equal to angle Q. We can say that from similarity that triangle ABC is similar to triangle PQR. The corresponding sides will be in proportion for both triangles, that is AB by PQ is equal to BC by QR, which will be equal to AC by PR, which need not be considered, which implies AB by PQ is equal to BC can be written as 2 times BD, as AD is median for BC, and QR can be written as 2 times QM, as PM is median for QR, which is equal to BD by QM. Here in triangle ABD and triangle PQM, the corresponding angle, that is ABD is equal to PQM, and the corresponding sides, that is AB by PQ is equal to BD by QM. So by SAS similarity, we can say triangle ABD is similar to triangle PQM. We know that when two triangles are similar, then corresponding sides will be in proportion. So here the corresponding sides, AB by PQ is equal to BD by QM is equal to AD by PM. So let us consider the first and last term of the equality. Then we get AB by PQ is equal to AD by PM. This is what the required proof for us.